Hey guys, welcome back to Helper Function. In this video, we will be discussing a popular interview question, majority element. So the problem statement says that given an array of size n, find the majority element. And the majority element is the element that appears more than n by 2 times. So if n is 8, then majority element should appear at least 5 times. And if n is 7, then majority element should appear at least 4 times. You may assume that the array is non-empty and the majority element always exists. Thus, the problem guarantees that there always exists a majority element and we just need to return that element. So for this example, 3 appears 2 times, which is greater than n by 2, thus we return 3. And for the second example, n is 7, thus n by 2 is 3, and because 2 appears 4 times, we will return 2 as our answer. So let's see how to solve this. Now the brute force approach to solve this problem would be to go through every element, and now for every element take another loop to count its total occurrence. Now if this count is greater than n by 2, then we will return this element, otherwise we will keep checking. Now because the answer always exists, we will definitely get an element whose occurrence is more than n by 2. But this approach requires two for loops, one for going through every element and another for calculating its total occurrence, thus making its time complexity order of n square. Now another approach is, in one go, we store the count of each element in a map. Now again we go through these elements, and if map of any element is greater than n by 2, we will return that element. Here nums of I represents the element of the array. Let's say for this example, I have gone through each and every element and store its count in a map. Thus, after the completion of the loop, map of 1 will have 3 and map of 2 will have 4, which represents nothing but their count. Now I will again go through every element, and at the first index only I can see that map of 2, that is 4, is greater than n by 2, that is 3. Thus here only we have got our answer and we will return 2. Now the time complexity to solve this problem is order of n, as we are using a single loop. But the space complexity here is also order of n, because we are using a map to store the frequency of every element. Now there is another approach that can solve this problem in order of n complexity without using any extra space, and that's what our main motto is. So let's see how to do that. Now we will be using Boyer-Moore's voting algorithm to solve this problem. Now the basic idea of this algorithm is, if we cancel out each occurrence of an element k with all the other elements that are different from k, then k will exist till end if it is a majority element. Now what it means that is, let's say k is our majority element. So if we take a counter variable and increment the counter every time we get k, and we decrement the counter every time we get a number other than k, thus at the end of the loop this count should be greater than 0, because the occurrence of k is more than n by 2 times. Now if you are still confused, let's get into the algorithm and understand by example. We initialize count as 0 and an integer k, which will represent our majority element. Now for every element, now if count is 0, this means that we have not got any candidate for majority element, and we will take this number as our candidate to majority element and increment its count by 1. Else if the number is k, that is, it is same as the candidate majority element, then we will increment our count by 1. Otherwise, we will decrement our count by 1. So after the end of this loop, k will automatically represent the majority element, and thus we will return k as our answer. Let's try and understand by this example. Initially my count is 0. Thus for the first time I encounter 2, k will become 2 and count will be 1. Thus we assume that our candidate majority element is 2. Now in the next step, as count is not equals to 0, we will move to the second condition, and because k is equals to 2, count will be incremented by 1, which makes it 2. Now in the next step we have element 1, and because it is not the candidate majority element, my count will decrement by 1, which makes it 1. Again the same thing will happen, and this time my count will become 0. Now here my count is 0, which means that number of times 2 have appeared is same as the number of times elements other than 2 have appeared. Thus 2 cannot be the majority element at this point of time. So now our new candidate to majority element is 1 and count also becomes 1. Now in the next step, because count is not equals to 0 and also k is not equals to 2, count will be decremented by 1, which makes it 0. And now again count is 0, which means that the number of times 1 has occurred is same as the number of times elements other than 1 have occurred. Thus 1 cannot be the majority element at present. Thus k is now 2 and count is 1. And now as the loop has ended, we can see that k automatically represents the majority element. Thus we return k as our answer. Let's try out another example. So for the first index, because count is 0, k will be 2 and count will become 1. Now for the next index, neither count is 0 nor k is equals to 1. Thus count will reduce to 0, which means that the number of times 2 have occurred is same as the number of times elements other than 2 have occurred. Now in the next step, because count is 0, k will become 1 and count will also become 1. Now because k is not equals to 2, count will decrement by 1, making it equal to 0. And now for the last index, because count is 0, k will become 1, which it is already, and count will also become 1. Thus at the end of the loop, our answer is 1, as it has appeared 3 times, which is more than n by 2. Thus we were able to solve this problem in order of n time complexity in single traversal. And also no extra space was required. Now let's quickly look at the code. The code is similar as the algorithm says. We take an integer count initialized to 0 and an integer k, which will be our candidate for majority element. Now in the for loop, if my count is 0, we increment our count by 1 and now k will represent this element as the majority element. Else if k is equals to this element, count will increment by 1, otherwise count will decrement by 1. And finally, after ending this loop, we will return k as our answer. So this was all about the problem. I put the problem link in the description so you can go and solve it. If you have any doubts, then please write in the comment. And if you have not subscribed this channel yet, then please hit that subscribe button. Thank you for watching.